Hello and welcome to another one of these videos where we solve some design or engineering challenges using Alibre, right? So here I've designed a glass or a vase. It's basically a vessel of some sort. And I would like to know the exact amount of volume it can hold on the inside. So if I fill this up with water, what exactly will be the volume of that water, right? So let me just tell you, first of all, that this is 135 millimeters tall, right? And at its widest, it's about 60 millimeters, okay? So we know these things about this container. So how are we going to figure out what's its internal volume precisely? Well, what we do is we go ahead and create a new part, right? And I'm going to design in the XY plane. I'm going to make a cylinder that's sure to be larger than that glass. And we saw that the glass is 135 millimeters. Well, let's say that we want the volume 5 millimeters from the top, right? We fill it to 5 millimeters from the top, to within 5 millimeters from the top. What is that volume going to be? Okay, so I designed this cylinder that is surely larger than the glass and that it can encase the glass completely. And if you have been watching my videos, I'm sure you will know what comes next. So let's do a Boolean subtract. We'll bring that vase in, right? Okay. I'm going to turn the reference geometry on because I want to place this perfectly, right? Okay. And I want the bottom of this container to be on the bottom of the cylinder. There we go. Now let's turn off the references for this part. Okay. And now that I've assembled it, I just hit the check mark. And look what happened here, right? So there was a cut. And if I do a section view of this, you will see that not only did it cut it, but it actually separated this cylinder I designed into two different solids. And the inner solid is precisely the volume I'm looking for. Now, if I go back here and I click this drop-down menu in the direct editing part of the toolbar, right, there's a command that says remove model pieces. So I want to remove the outer piece. And if I also stop this section view, what I am left with is the actual inside volume of that glass. Okay, and I can just go calculate it, and the volume is precisely 79,031 cubic millimeters. That is 79.031 cubic centimeters, right? So this would weigh 79 grams, thereabout, if this was water, right? Just to give you an idea. Okay, so I have this volume, right? And it's completely correct, and I can even save it. Okay, I can save it. I can call it volumetric vase volume. Inspired naming, as always, in my channel. Now, here's the good part, right? Here's the fun part. Let's go and play with this glass a bit. Okay, yeah, and actually this makes more sense as a glass now, but whatever. We'll save this, and let's open the there you saw it for a minute. Let's open this up. It has adjusted. This is parametric, guys. This is the inner volume of that vessel, and it's parametric. And now I can get the measurement again, and this time is 171,000. So this would weigh 171.3 grams if it was made out of water. Okay, so this is how you get the volume of the inside of a vessel. How you can oh, the fillet failed. I'm sure the fillet fell down there. You see, it's so precise. It's so precise. If we go back to the vase, I'm sure the fillet has failed on the bottom. And sure enough, here's the failed fillet. So this is how you do it. It's very precise. It's very accurate, and it's very useful and powerful when you're doing stuff like containers, vessels, tanks, reservoirs, or whatever, right? When you need to know the precise inner volume of a structure. That's how you do it. Super powerful, super helpful. Subscribe if you want more videos like this. Like if you liked it, and dislike if you didn't like it, because I still need to know if you didn't like it. Thank you for watching, and I'm going to see you in the next one.